Hello friends. So in today's question, 4 blocks and 2 springs are arranged as in figure. So these are M1, M2, M3 and M4 4 blocks. The system is at rest. Determine the acceleration of all the loads immediately after the lower thread keeping the system in equilibrium has been cut. So this is a lower thread and this is keeping the entire system in the equilibrium. Assume the thread are weightless, the mass of the pulley is negligible and there is no friction at the point of suspension. Okay. So this is the point of suspension of the pulley and this is the thread which is keeping entire thing in the equilibrium. So first of all, let us see this is the tension T in the thread and the spring constant is given as K, and we assume that the force is F1 is acting for the spring number 1 and force F2 is acting to the spring number 2 when the spring is not cut. So these are the forces before the spring is cut. So you can say that let T be the tension in the string and the force on the, let us call this as spring 1 and let us call this as spring 2, force in spring S1 is F1 and force in the spring S2, force in the spring S2 is F2. Now it is given that the lower thread is keeping entire system in the equilibrium. So it is given that this is our lower thread. This is our lower thread. It is given that lower thread is keeping the system in equilibrium okay. So it means the blocks, these blocks will be try to balance the blocks on the left side. So there is a balance. So under this condition, we can say that under this condition M1 plus M2 should be greater than M3 plus M4, because normally what is going to happen if this condition is not maintained, this is a pulley, so entire this thing will be pulled by the lower thread and it will be traveling in this format, so there will be no equilibrium. So let us analyze the equation, this figure. So it is given that the equilibrium, let us say this is mass M2 and it is going to have a force in the downward direction that will be equal to M2G, okay, and it is going to have force F1 in the upward direction. So you can say that for mass M2, and this is under equilibrium. Okay. For mass M2, we are going to have F1 will be equal to M2G. Let us call this equation number 1. And similarly, let us draw for M2 here. It's much more easier. This is our M2. There will be M2G in the downward direction, and there will be force F1 in the upward direction. Next is our M1. Okay, so M1, it has F1 in the downward direction, and also there will be M1G in the downward direction, and upward there will be tension T. So we can say that for M1, for mass M1, you can have T is equal to F1 plus M1G. Let us call the equation number 2. So using from equation 1 and 2, from equation 1 and 2, 1 and 2, using F1 from 1, substituting in 2, you can say that tension T will be equal to M1G plus M2G, and it can be written as M1 plus M2 times G. Let us call this equation number 3. Now we come to mass M3. Okay. You can see that for mass M3, so this is our mass M3, and it is going to have T in upward direction, and downward there will be M3G, and there is force of F2. And so under this condition, you can say that tension T is equal to F2 plus M3G, and let us call this equation number 4. And we know that the tension is given as M1 plus M2 multiplied by G from equation 3 and 4. We can say that F2 plus M3G is equal to M1 plus M2 times G. From here we can write what will be our F2. F2 will be equal to, taking G as common, this will be M1 plus M2 minus M3 times G. Let us call this equation number 5. Now what is going to happen? Under second condition it is given that the thread is cut. Okay. So you can say that when the lower thread is cut. When the lower thread is cut, let us draw the figure here. M1, this is a spring, this is our M2, and we have M3 and this is our M4, and we already know that tension is T, tension T, F1, this is spring 1, and we have F2, this is F2 and this is spring 2. And in this case we say that these are moving with the acceleration. M3 is moving with the acceleration A3, M4 is moving with the acceleration A4, this is moving upward in the direction A1, sorry, downward with A1, and this is moving downward with A2. When the lower thread is cut, acceleration of M1 is A1, M2 is A2, M3 is A3, and we have M4 is A4. Now the important property of the spring is that there is no as such sudden changes in the spring. Okay, so we can say at T minus and T plus, the situation in the spring for the instant remains the same. So there is no sudden change in the spring. We can say that at the instant of cutting the lower thread, the extension in the spring is going to remain same. Okay. So we can say that cutting the lower thread, the extension in the spring springs S1 and S2 is going to remain same. Okay. So they are going to remain same. So we can say that thus therefore the forces will also remain same. Therefore the forces F1 and F2 will also remain same. From here we can conclude that the forces F1 and F2 before cutting the spring and after the cutting spring will be same. So we can use the previous formula for F1 and F2 which we have already calculated. Okay. So it means that F1 and F2 before cutting is equal to F1 and F2 after cutting. This is simple. Okay. That is also given, or rather we can say for the equilibrium M1 plus M2 is greater than M3 and M4. So obviously every movement will be M3 and F4 will be going upward, A1, A2 will be going downward. Okay. As we can say, since M1 plus M2 is greater than M3 plus M4, okay, so we can say that blocks on the left will be going down and blocks on the right will be going up. Okay, you can say that blocks on left, that is M1 and M2, goes down, and blocks on the right M3 and M4 goes up. So from here we can say A1 will be in downward direction, A2 will be also downward direction, A3 will be in upward, and A4 will be also in upward direction. Next we are going to simply calculate, okay, using the Newton's second law of motion. We can easily simply calculate. You can say that for block M2, we are going to have M2G in the downward direction, M2G, and minus F1 in the upward direction, and there will be acceleration produced of A2. Okay, so simply we can draw the diagram also. So we can say this is M2, we have M2G, and we have A2, and this is our F1. And we have already found that our F1 we already found. We are going to put the value here. So using equation 1, okay, F1 is equal to M2G. Okay. So we can say that from equation 1, and let this be equation number, this will be 6. From equation 1, in equation 6, F1 is given as M2G. So you can say that M2G minus M2G is equal to M2 A2, and from here we can say that M2 A2, okay, from here we can say that M2 A2 is equal to 0. So obviously mass cannot be 0. Okay, M2 cannot be equal to 0. From here we find out that acceleration A2 is equal to 0. Okay. Now similarly we do for block M1. For block M1 we have M1 G1 plus F1 minus tension is going to give us M1 A1, and we already know what is the tension. We put here and we solve it. Okay. We also know the value of F1, we also know the tension. Okay, let this be equation number 7. So now using equation, it is 1 comma tension is equation number 3, using equation 1 and 3 in equation 7, we substitute the value. This is F1 G1 plus F1 is given as M2G, and tension is given as M1 plus M2G. We open the bracket, we get M1G minus M2G is equal to M1 A1. So M2G and M1G cancel out. So from here we get M1 A1 is equal to 0. So this implies that A1 is equal to 0. Now for block M3, block M3 we get T minus M3G minus F2 is equal to m3 a3. And let this be equation number, this will be 8, equation number 8. Okay. So using equation number 3, that is the tension equation, and F2, that is equation number 5, and equation 5 in equation 8. So we know tension is given as m1g plus m2g minus m3g minus F2 is given as m1g minus m2g plus m3g is equal to m3a3. So we have m1g, we have m2g, and m3g. So this implies that m3a3 is equal to 0. So as mass cannot be 0, so from here we can conclude that our a3 will be equal to 0. Now next is our for block. For block M4, we can write the equation as F2 minus M4G is equal to M4A4, and let this be equation number 9. And we already found out what is our F2. F2 is equation number 5, so we can say using equation 5 in equation 9. So F2 was given as m1g plus m2g minus m3g minus m4g is equal to m4 times a4. So here, taking g as common, you can say that this will be m1 plus m2 and minus m3 minus m4 times g is equal to m4 times a4, and this implies that our acceleration a4 will be equal to m1 plus m2 minus m3 minus m4 divided by m4. So we can clearly see that acceleration of the blocks immediately, you can write here acceleration of blocks immediately after cutting the lower thread, is, or rather are, block M1, which is having acceleration of A1 is equal to 0. Block M2, which is having acceleration of A2 is also equal to 0. Block M3, acceleration of A3 is also equal to 0. Okay, and finally block M4, which is having acceleration of A4, which is given as M1 plus M2 minus M3 minus M4 divided by M4. This completes the question. Thank you.